Hello math fans. Alright, so we're going to do just more trig functions. And the first type of problem we're going to do is I'm going to give you guys the quadrant. So you're going to be given the quadrant. And the question I'm going to ask you is the ratio positive or negative? Okay, it's pretty easy. I mean, basically, remember the ratios are all our different trig functions. Okay, so here's a bunch of examples. Here's the quadrant 4, and we're looking at x over r. Is it positive or negative? Well, I mean, if you need to make a quick sketch here, quadrant 4 is here. Well, isn't x positive there? So the ratio, and of course you always know, r is always greater than 0. That's given. Alright, so really you're just looking at what x is here, and x is positive, so the ratio is positive. Okay, here's another one, quadrant 3, and x over y. So we're here, well, x is negative and y is negative. So it's basically negative over negative, which is a positive. So the ratio is positive. Okay, quadrant 2, x over r. We're over there, x is negative, so it's basically a negative over positive, and that gives us a negative. Okay, that's pretty easy. All right, let's try another kind of problem here. Okay, given the equation of the terminal side of angle theta. So given the equation of the terminal side of angle theta in standard position, of course, and what you have to do is you have to sketch the smallest possible angle. Okay, so here, this is what I mean by that. I give you an equation, 3x minus 2y equals 0. Alright, and I have to give you a little more information here. X is going to be greater than or equal to 0. So basically what you're doing, there are a couple ways to look at this. One is it has to be 0, or it has to equal 0. Okay, so if that has to be greater than or equal to 0, you could put there's actually an infinite number of solutions to this problem, giving you this equation, right? Because basically it's a line. But what I can do is, let me just kind of give you the answer, and I'll kind of work backwards from that. If I tell you the answer is 2, because of course x is greater than 0, so that's 6 minus, doesn't have to be 3, that gives you 0. Okay, that's kind of the way you look at it, but you're basically taking that y value and that x value, but you got to be careful of your signs. So that would be the smallest possible angle, and if I would sketch that, it'd be 2, 3. And there's your sketch. Alright. Now, a couple things I can tell you to do with this. I can tell you to find all, let's see, I'll write this down here. Find all the trig functions. Alright. And, well, obviously, what else do I need to do here? I need to find out the value of r. So it's just r squared equals 2 squared plus 3 squared. So r comes out to be the square root of 13. And then it's really easy, all the trig functions. So sine of theta is equal to y over r. So it's 3 over root 13, which is 3 root 13 over 13. Cosine of theta equals x over r, which is 2 over root 13, which is 2 root 13 over 13. Tangent of theta is equal to the yax, so it's y over x, so it's 3 halves. Cosecant of theta, which is the reciprocal function of sine. Again, work with this guy here, man. I mean, I don't know why you would work with the one that's already rationalized when you can look at it and just say, oh, it's reciprocal of 3 over root 13 is root 13 over 3. And then secant of theta is reciprocal of cosine, so it's root 13 over 2. And then, of course, cotangent of theta is the equal distant cousin to psi, and that's 2/3. Okay, that was pretty easy. But again, watch this part right here. That's the smallest possible angle, the 2 and the 3. All right, so just real quickly, if I gave you another example, how about 5x minus 2y equals 0? And I tell you x, of course I have to tell you that if x is positive or negative. I tell you if one of them is positive or negative. All right, so x is less than 0, so that's going to be a negative 2 here for x. All right, and if I put a negative 2 in here, I get negative 10. And don't I need to add 10 to that? So doesn't y have to be negative 5? Okay, and that's going to be, that's if I just ask you the numbers, right, to make the sketch. Okay, because even here, negative 2, negative 5. And that's actually at theta right there. All right, and even if I would graph this thing, if I would have actually solved for this, it would be negative 2x equals negative 5x, or y equals 5 halves x. That's the equation. Well, isn't that the equation here? Right? I could go up 5 over 2, or I could go down 5 over 2, which is back to this point here. So really, that's my equation here. And then I give you this piece of information because you need to know, is it the positive part here? Is it this angle here, or is it this one going all the way around? Okay? So let's try it. This is a little tricky one. Negative 2x minus 8y equals 0. X is greater than or equal to 0. Now I know it's tempting to say, well, I can just do opposite of that, right? Can I just say that's going to be 8, and so if I put an 8 in there, that's negative 16, and then it's got to be negative 2, right? Of course, x is greater than 0, that's why that's positive 8 here. Now that's definitely a possibility, but remember, I'm looking for the smallest possible angle. And what you could do is actually you could simplify this equation before you even started, right? Negative 2x minus 8y equals 0. Can I divide everything by negative 2? That was simplified to x plus 4y equals 0. Well, again, x is greater than 0, so I know it's going to be a 4. And basically what you're doing here, if you haven't kind of figured out the pattern, one's positive, one's one value, and one's the opposite value, okay, to make it work. All right, so it's 4, comma, if I put a 4 in here, it's going to be negative 1. Okay, all right, very good. Let's talk about the trig values. Trig values of quadrantals. And you're like, what are quadrantals? Well, think of what the word is. It's quad, right? 4. So quadrantals are at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. That's what a quadrantal is. All right, and if I actually made a quick sketch here of what the coordinates are, let's just call this 1, 0. Let's call this 0, 1. Let's call this negative 1, 0. And let's call this 0, negative 1. Okay? So we can kind of work our way around here let's do sine of 0 degrees. Well, remember, sine is, let's just write that on top here, it's y over r. So if I look at 0 degrees, which is our first guy right here, 0 degrees, it's 0, and r, for all these problems, guys, r is always equal to 1, right? In fact, what we're doing here is, if you notice, our circle right here, this is called a unit circle. Unit circle, it's got a radius of 1. Alright, so that's kind of nice. A radius of 1, there we go, r is equal to 1. Okay, so sine of 0 is y over r, which is 0 over 1, which is 0. So sine of 0 is 0. And then you have sine of 90 degrees is also y. So it's all y over r. So y is 1. So it's 1 over 1, which is 1. Sine of 180 degrees is 0 over 1, which is 0. And sine of 270 degrees is negative 1 over 1, which is negative 1. Okay? Very important. Now, if I kept going here, sine of 360 degrees. Well, isn't that going all the way back around the circle? So I'm back to 1 comma 0. So isn't that the same thing as 0 over 1, which is 0? Right? That makes sense to everybody? I hope it does. And also remember, 360 degrees, isn't that coterminal to 0 degrees? Okay, so I could say 720 degrees would still be the same as the 0 degrees because they're coterminal. All right. Okay, so I want to just on the same page here, I want to do cosine. So cosine is, of course, x over r. So cosine of theta, if I do x over r, I'm going to get 1 over 1, which is 1. Oops, and that's cosine of 0 degrees. Cosine of 90 degrees is 0 over 1, which is 0. Cosine of 180 degrees is negative 1 over 1, which is negative 1. And cosine of 270 degrees is 0 over 1, which is 0. Of course, then we come all the way back around to 360, just like sine. Cosine of 360 is 1 over 1, which is 1. All right, not too bad. And so, if you notice, for all these problems, our range is between negative 1 and 1. That's our range. Okay? And it keeps repeating. Between negative 1 and 1, negative 1 and 1 all the time. So, and then let's see. We can fit tangent in here. If I did tangent of 0 degrees, it's y over x, which is 0 over 1, which is 0. Tangent of 90 degrees is 1 over 0, which is undefined. Tangent of 180 degrees is negative 1 over, or 0 over negative 1, which is 0, and then tangent of 270 degrees is negative 1 over 0, which is undefined. So it's undefined on top here and the bottom here for tangent. And the rest of them are really easy, okay? Because they're all reciprocal functions, right? Secant and cosecant and cotangent. You just find out the reciprocal first, and then you just flip that, and you get the answer. Okay? So, for example, just having all this on here, I can say, hey, what is the cosecant of 180 degrees? Well, isn't that, doesn't that go with sine? So sine of 180 degrees right here, it's equal to 0. So this reciprocal 1 over 0, well, it's undefined. Okay? Not too bad. I want to do something that's talk about tangent here. You guys know already tangent of theta is equal to y over x. Well, let's just do something kind of fancy schmancy here. What's sine of x over cosine, or sine of theta over cosine of theta? Well, isn't that y over r? Isn't that what sine is? Divided by x over r? And doesn't that turn out to be y over r times the reciprocal? And the r's cancel, and we get y over x. Interesting. Okay, so really the tangent is y over x, which is sine over cosine. Okay, so that's kind of an interesting thing, but it's very important to understand that. I think it kind of allows you to kind of remember sine and cosine, and then not even have to worry about tangent. If you know tangent is y over x, or it's sine over cosine, then you just have to memorize sine over cosine. All right, and just remember, of course, cosecant of theta is 1 over sine of theta with your quadrantals, and secant of theta is 1 over cosine of theta, and cotangent of theta is 1 over tangent of theta, or it's if sine over cosine is tangent, isn't cotangent cosine over sine? Very interesting. Okay, so I'm trying to get you guys to get a couple ideas here where you don't have to do as much memorizing, because memorizing is sometimes kind of difficult to memorize all these different numbers in math. All right, so let's do a couple basic problems here. First of all, 3 sine of 90 degrees. What you're going to do is you're going to find the sine of 90, and then you're just going to multiply it by 3. So 3 times sine of 90 is 1, so the answer is 3. That's pretty easy. Okay, 4 sine squared of 270 degrees. This is the deal. People sometimes get confused with this. What this means is 4 times sine of 270 squared. That's important. Okay, you got to find the sine of 270 and then you square it. Don't square the 4. Don't square the 270 degrees. It's the sine of 270 squared. These are equivalent. That's super important. All right. So sine of 270 is -1, so it's 4 times -1 squared, which is 4 times 1, which is 4. Okay, not bad. How about 5 cosecant of 270 plus 3 cotangent squared of 90 degrees. Okay, that looks kind of brutal, but you know, it's going to take you a little bit of time, and eventually this does get a little bit easier. So again, I don't choose to memorize cosecant, but I do choose to memorize sine. I know cosecant goes with sine, so the sine of 270, I'm going to write this out here, sine of 270 degrees is -1. So the reciprocal is 5 times -1 over 1. I'm taking the reciprocal, which is still 5 times -1. Okay, cotangent of 90. However you choose to do that, if you kind of look at it here real quickly, you know cotangent is x over y, and this is 0, 1. So x is 0, y is 1. So isn't that plus 3 times 0 over 1 squared? So it's -5, and that's just 0. So plus 3 times 0, which is -5. We'll try our calculators out in a little bit. Okay, just type in sine of 90. That's all I do. But the key here is calculators must be in degree mode. Most of them are now, but make sure, because some games or some applications change things into radians. So your calculator has to be in degree mode. Very important. Okay, so you can do sine of 90 in your calculator, and of course you're going to get 1. Okay, if I do tangent of 90 degrees, it's going to give you an error. Please don't give me that as an answer. That's a very bad answer. You're going to tell me it's undefined. All right, so this is actually really key here too. To find the secant of 90 degrees, what you do is that's equal to 1 over the cosine of 90 degrees, which is 1 over 0, which is undefined. Okay? That's important. So what you can do is you can either set up this way, or you can say cosine of 90, hit equals, and it'll give you 0, and you can use the 1 over x button on your calculator. Okay, that's going to give you an error, which is, of course, undefined. Okay, but again, don't give me error. That 1 over x is a really nice feature. This is really, 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 really bad. You see this little sign to the -1 on your calculator? Okay, do not use for 1 over sine of theta, or inverse cosine or inverse tangent. Do not use it. That does not mean 1 over. That's actually called the inverse. That's how you find the angle. Okay, this is really bad. Boo. Okay, don't use the inverse button to find secant, cosecant, tangent, or cotangent. Your calculator doesn't have a button for those. You're just going to have to deal with it by doing the 1 over button for your answer. Okay, going back to secant of 90 degrees, that is equal to 1 over cosine of 90 degrees. Okay, another bad thing to do is to do cosine of 1 over 90 degrees. That's really bad too. Okay, because this doesn't even make sense. This is saying, hey, I'm taking the secant of 90, let's take the cosecant of 1/90th of a degree. How 1/90th of a degree and 90 degrees have no relation at all, right? It's completely random, so that is really, really bad to do that. You want to do 1 over cosine of 90. That's super, super important. All right, that's it, math fans. I hope you guys learned something about all this stuff, and have a good day. Goodbye.